Alright, so this is going to be day 2 of the 30-day scripting challenge. Yesterday was the leader stat system, which we have right here. And today it's going to be a bit harder than yesterday. Today we're going to be making a tool system, in this case, a sword. Now, they're really easy to make, even though they look complicated. They're not. And I can show you guys how you can make a sword system from scratch, right? So I have a katana here already. It's just a model of a katana. There's no scripts inside of it. It's just a free model of a katana. To start, we're going to have two different scripts. We're going to have a client script and a server script. The client script will wait for when the player interacts with the katana, and the second one will be listening for when the player interacts with the katana and they fire over a remote event to the server. So what we're going to do is we're going to make a local script, put it in starter GUI or starter player scripts, and name it whatever you want. Right? So what we're going to do is we're first going to get this katana that we have in the backpack. So to that, we're just going to access the player's backpack and we're going to search for the katana. So local player is game.players.local player, and then local backpack is going to equal to player.backpack. Now, there's two different methods to getting the katana. The first one would be to just search for it directly, and the second one would be to loop through the player's backpack until they find a tool which is called katana. In this case, we're just going to loop through because it'll work for multiple tools, but I guess we're just going to do that method. So for blank weapon, and we're going to give that the tool context, or weapon in backpack colon get children do, and I'll check if the weapon colon is a tool and weapon dot name is equal to katana. Then also I just realized I spelled that as Katan, not katana. There we go, katana clap. So if the weapon is a tool and the weapon's name is equal to the katana, then we're going to check for if the weapon's activated. Now, for simplicity, we're just going to have it only run in here, though I know you can also call functions outside of it to have it run however you need to. So what we're going to do is we're going to check weapon.activated colon connect function. This will only run once the player clicks on the katana when they hold it. So we can run print and we can say weapon.name activated. So now what we can do is we can go into replicated storage and we'll make a remote event called attack, which I've already made here. So we're going to get the replicated storage. So local replicated storage. Let's go to game.replicated storage. And then the attack event is going to be replicated storage.attack event. So I would recommend when you're coding to use a snippet plugin so you don't have to always retype your variables when you're making a new script. For simplicity and for ease of demonstration, on the first week of the scripting challenge, I won't be using snippets so you guys can see the variables I'm doing. Then after that, when we get to more complicated things, I will be using snippets. So we're going to fire the attack event colon fire server, and that's all we have to do for the client. So now we're going to make a server script inside of server script servers, and we're going to be calling it Katana server, and we're just going to copy over these variables here, and we're going to say attack event dot on server event colon connect function, and the player is passed by default as the first variable. Don't forget that. So we're gonna have the player in there, and now we're going to run our attack logic. So usually when we're gonna attack, we're gonna have an animation that'll play with the attack, right? So we're gonna create the animation. So local animation is going to equal instance.new animation. and then the animation ID is going to equal, in this case, whoops, I have an animation ID. Let me go on ahead and grab that real quickly. So we're going to have an animation ID for the thing. Now, always note that this animation is made in R6. So if you want this animation to load onto your player's character, make sure that your player is in R6 or else this won't work. Now what we're going to do is we're going to check for the player's humanoid because that's how we run animations. So local humanoid going to equal to player.character colon find first child of class humanoid. And then if not humanoid, then return end. Because if there's not a humanoid, that means the player's dead, and we don't want to continue the rest of this function if the player is not alive. So now, once we have the humanoid, we're going to say local animator is going to equal to humanoid dot animator, or humanoid colon find first child of class animator. And then we're going to say animator. Actually, we're going to say local track is going to equal to animator. We're going to load animation, and then our animation right here. And then we're going to call this an animation track right here. So, once that's all set up here, we're going to run the rest of our thing, right? So we're going to want to wait until like the katana actually hits the target to then deal damage. So what we're going to do is we're simply going to say track colon get marker reached signal. And then in this case, in this katana attack animation, there is an animation event called hit, which is when the katana makes contact with the enemy. Now if your animation doesn't have a animation event called hit or like attack or whatever, then this line won't work. Because without an animation event, there's no way to know when the katana actually is going to hit and register the damage for whatever it's hitting. So anyways, we're going to connect this to a function, and this is just going to run every time this hit thing plays in an animation. Now, once we're connected into this function, we're going to want to set up our attack, right? So first, just for debugging, we're going to put a print hit right there, so we know that the thing is successfully running. And then we're now going to do a couple of things here. So first, we're going to get the humanoid root part of the player, and we're going to get its look vector, which is basically what direction it's facing. And then with that, we're going to make a dot product to see what humanoids are within a certain radius of the player's look vector. That'll determine if the katana should hit the enemy or not. So to do that, I'm just going to get our root. So we're going to say local root is going to equal to player dot character colon. Actually, we already have the humanoid. Wait, no, sorry, I got that confused. Humanoid root part. So local root is going to equal to player dot character dot primary part. I got that confused with the humanoid first. So if there's on a root, we're going to cut it off here, because that means the player's dead and we don't want this to continue. So what we're going to do now is get the look vector. So we're going to say local forward, or look vector, whatever. Is going to see root.cframe.look vector. It's as simple as that. Now this is going to be a little bit advanced for people who are completely new to coding in Lua, but it's really easy to understand once you visualize it better and like look into it a bit more. In this case, I'll definitely link the documentation in the description so you can check it out as well. So what we're going to do is we're going to loop through, and this is, by the way, not optimized, but this is how I'll do it in this video, just for simplicity. We're going to loop through every single instance in the workspace, Actually, I don't need to do that. No, whatever. We're gonna loop through every single instance in the workspace, and wait, not get children, get descendants. Sorry. And what we're gonna do is we're gonna check if that target is a model, and whoops, and the target is not equal to our character. Because we don't want to damage ourself when we're hitting. So now what we're going to do is we're going to check if the target has a humanoid. So local humanoid is going to equal to, actually, local target humanoid is going to equal to target colon find first child of class, find first child of class humanoid, and then we're going to find the root part of the target. So then local target root is going to equal the target dot primary part. So if not target humanoid or not target, actually we don't even need to do this. So if target humanoid and target root, then so if both of these exist, that means it's a model that has a primary part that we can damage. Then we're gonna run this, right? And these next couple of lines are gonna seem super complicated, but they're really easy to understand once you're able to like look into it a bit more. So the first thing we're gonna do is we're going to get the offset and our distance. To get the offset, we're just going to say local offset is going to equal to the target root dot position minus the player root dot position, right? And now you can just like have the distance be calculated here, but I'll just make it another line so you guys can see how it looks. So local distance is going to equal the offset dot magnitude. Now you can just put this entire thing in parentheses and type dot magnitude right after and have that be the distance variable, but this is just so you can visualize it a little bit easier. Now once that's done, we're going to say if the distance is less than or equal to 6, right? Which is going to be, this is just a placeholder value of our like range of how far the katana can hit. Now you can set this as a constant up here or as like a value passed like with the attack function, but we only have one katana and this is just one attack, so it'll have a range of 6 that we're going to set here. So if the distance is less than or equal to 6, that means they're in range. So now what we're going to do is, this is the hardest part, okay? We're going to get the direction, or the unit basically, and then we're going to make the dot product from that, which is something I don't want to explain in this video. It's something that you should watch a completely other video for. This is just like the series that you should follow, right? So the local direction, or dir for short, is going to equal to offset dot unit. And then the dot product is simply local dot. It's going to equal to the, it's going to equal to our forward, like our look vector. And then we're going to say colon dot, and then our direction. Then we're going to check if the dot is greater than or equal to the cosine of our like angle, which is how wide we want our melee angle to be. In this case, once again, it's only going to be one attack on one katana, so it'll be a placeholder value right here. Now, because it is a cosine, it needs radians. So we do math.radian, and we're going to put in 60, because we want it to be 60 degrees, right? And it's important this has to be radians, because if you put in degrees, it's going to take out, it's going to probably give like an error. I've actually never tried that before. So if the cosine, right, this is our how wide the attack can be. If it's greater than that, then we're going to have the target's humanoid take damage. So target humanoid, take damage, 1, and then we're just going to say print hit successful. And that's all it is for this entire attack function. This is it, basically. I forgot to add the track colon play here. Whoops. And now as you can see, the attack will, and it's actually spam attacking. So hold on just 1 second here. It's a super simple solution. What we can do is we can, we're gonna put a value inside the player. So if player colon find first child's CD, then we're just gonna put a value inside the player called cooldown, which will pretty much tell if the player is allowed to attack, right? So if player.cd, then we're just going to run all this, right? And it'll make more sense in a second here, because we're gonna have the CD value be a boolean, right? And then we're gonna say else. In this case, if not player CD, we're gonna say return, right? Because we would, actually no, hold on. Else if not player colon find first child CD, then local CD is going to be instance instance.new bool value, and then cd dot name is going to equal to cd, right? And then cd dot parent will equal the player. Now what's gonna happen here is we're gonna say cd dot value equal to. Now in this case, when this happens, we're going to set player.cd.value equal false, and then when this track is over, we're going to say player.cd.value equal to true. So to summarize what I did here is I added a value inside the player that will determine if the player can attack. When cd is equal to true, then this will run and it will set it to false so the player can't spam attack, and when the attack is done, it'll set the value back to true so the player can attack again. So now if we run it, I can now still spam click it. Hold on. Okay, there we go. So you just have to set this equal to true thing here, and then now when we jump in, the player will not be able to spam click the katana, but they'll be able to attack, right? So now let's test this with a NPC to show that the damage is working. So I'm just going to go on ahead here and insert an R6 rig right here, and we're going to go into its humanoid properties, and we're going to say health display type always on, display distance we'll do 10, display distance type is going to be viewer. So now we can see our health, right? And then the health should be 100, right? So now if I test it, I get the katana out, and I go over to this dummy, and then I do the attack. If you look very carefully, you can see the R6 dummy is now taking damage. And it also works with shift lock too. Now if we get out of range, see he's not taking damage. But now, if I go in here, he's taking damage. So that's it for this system. Here is the final Katana server script, which I definitely can leave in a paste bin if you would like to copy this system for your own, but you will have to make improvements on it, because this on its own just showcases the bare bones of a katana attacking system. It still can have a lot of improvements. So yeah, that's all it is really. So if you say want to make new abilities, you could just check if the weapons equipped here, and maybe if the player presses R, then it'll fire the attack, but it'll send ability 1 here, so it'll check if ability 1, then instead of running this, it'll run a different set of code, This this is just how you can understand what a melee system would look like. There's also other methods for detecting enemies in front, like a raycasting system, which I know is more traditionally used. This is just one method that I like to use and I still use right now. But yeah, I hope you guys enjoy, and let me know if you make any cool improvements to it or anything interesting. I hope this helps a lot of people get started with making their own katana systems, because I really love fighting games like Deep Woken. It's one of my favorite games. So yeah, that's all for this video. Thank you so much for watching, and have a great rest of your day.